Welcome to the Blockchain Hustle, where I take a look at some interesting plays of how blockchain technology is opening up new business vistas across multiple industries. Hello, everyone. This is your host, Meenu Serene, with today's episode on the importance of data in smart contracts. This episode is a part of the smart contract series, and I had shared about these contracts and the business applications in my recent episodes. Smart contracts, or the self-executing contracts, in them the actions are executed when certain conditions are met. So how do you know if and when those conditions are met? This comes from the data sources, that is the data triggers. For example, if I were to go back onto the flight delay insurance example, the data trigger is the one which tells the smart contract that the flight has got delayed by X hours, and then you can get your claim money. Now, in the insurance, smart contracts are contingent to the IoT data from cars, from flights, factories, other equipment, etc. In the trade finance or in the supply chain, they are contingent to the shipping or the goods movement data. Now, these data triggers, they can be internal or they could be external to the blockchain. Most of the smart contract, like the insurance one that I cited, or say a weather related one, they require the real world data, which is the IoT generated data or the legacy systems and so forth. Now, the internal data triggers are not an issue. However, when we come to the external data triggers, now that's a different ballgame altogether. Smart contracts cannot access the external data on their own, because if they were to do that, then any random data trigger can jeopardize the blockchain consensus mechanism. So that doesn't happen. Now, these real-time data feeds are called oracles. They're basically the middleware between your data and the smart contract. Now, do note that when we talk about oracles, these oracles are not the data sources by themselves. They are rather the data or the information suppliers. Now, being the trigger of the smart contract executions, this data or these data triggers are very important. These oracles, they need to be reliable, authentic, complete. Imagine what a chaos it would be if there were to be, let's say if there were some incorrect triggers, say a container shipment has not been received and then the money gets released. Or let's say a flight takes off on time, but the insurance releases the claim money. Yeah, I know the latter especially would never happen, but the point is that if we are looking towards a widespread use of the blockchain technologies, this is very important because most of the anticipated real-life use cases, they depend on this off-blockchain data. Now let's say we go to a centralized oracle. And let's say an entity, something that I can trust. So for example, I trust BBC for my news. But then when centralized oracles are taken, they are also the central point of failures. The blockchain is decentralized. Your smart contract is also decentralized. But now if you were to go for data triggers from a centralized point or a centralized node, it kind of defeats the whole purpose of decentralization. So the centralized oracles, going by their creditworthy reputation, etc., that is not a solution. Now let's go to the types of the oracles. Oracles can be software-based or they could be hardware-based. An RFID tag or a sensor in a container or a product is an example of a hardware oracle. It transmits the location data to the smart contract. And a software oracle could be, say, an application which feeds the information through an API. Say it could be the fluctuating energy prices, the wholesale prices, or could be the interest rates and so forth. Now, two qualities that the oracle should have is that of reliability and completeness. You need a reliable way to connect these smart contracts with the real world events. Who can be trusted to provide the data to the smart contracts in a trustworthy way? How do you get your oracle to be reliable, complete, and secure? And this problem is also called sometimes as the oracle problem. And the oracle problem is getting addressed in various ways by multiple entities. And I cite here a couple of well-known ones, which is ChainLink and the TownCrier. Now, ChainLink is an Oracle startup which uses multiple external sources of Oracle data. So it's not just one single source, but it kind of aggregates multiple sources. And it has developed its own weightage and consensus mechanism to validate its data feeds. Then there is another one called TownCrier. The word TownCrier actually refers to an officer of a royal court or a public authority who makes the public pronouncements as required. And so that's taken as the authentic one, the real version. The TownCrier system addresses the Oracle problem by using trusted hardware, namely the Intel SGX instruction set. Assuming that you trust SGX, the data which is delivered by TownCrier from a website to a blockchain smart contract is guaranteed to be free from any tampering. Now, I just wanted to make a point here that this secure enclave, in this particular case, SGX from Intel, this concept is not new. In fact, it has been there for quite some time in the semiconductor chips. But of course, blockchain is now leveraging this part to secure the data feed. In fact, this when you talk about wallets for a blockchain, the wallet data can also be available on this secure enclave. So SGX is one of the examples out here. Now, together these two systems, that is ChainLink and TownCrier, they allow for the smart contracts to interact with the real world events with a great degree of trust. So that's a pretty good example out here. So let me do a quick summary with the following points. Smart contracts are contingent on the events, mostly the real-time ones and external to the blockchain. Smart contract involved parties, they need to be able to trust the external data source. These real-time data feeds or oracles, they need to be reliable, complete, authentic, secure. Called the Oracle problem, entities like ChainLink and TownCrier, their efforts towards addressing this aspect, towards this problem. And this is important as most of the anticipated real-life use cases, they depend upon addressing this problem. So this brings us to the end of this episode. Thank you for listening and see you in the next one.